Okay, welcome back. This is Chapter 10, Lesson 2, Solving Inequalities. Okay, we remembered and introduced inequalities in the last lesson. Now we need to learn how to transform inequalities, change them up in order to solve them. Okay, so take a look at this. Only the first of the following statements is true. Negative 7 is less than 4. That's true. Negative 7 equals 4 is false. Negative 7 is greater than 4 is also false. Okay, so here is a comparison of numbers. The property of comparison. When you compare real numbers, we have to take this property for granted. It is just how things work. The property of comparison says, for all real numbers, so you pick any two numbers, A and B, then only one of these is going to be true. So if you pick any two numbers, there's no other options for what could happen here. It's either one of them is less than the other, it's equal to it, or bigger than the other one. You can't have any other situations. Okay. Now, suppose you know two facts about the graphs of three numbers, A, B, and C. The graph of A is to the left of B. So A is less than B. And you know that the graph of B is to the left of C. So let's think about this. So you know this number is less than this number, and you know that B is less than C. Then what do you have to know? You have to know that A is also less than C, no matter what the numbers are. If this is less than this, and this is less than this, then this has to be less than this. Okay, so that little journey into leftness tells us this. A couple properties. Transitive property. If A is smaller than this number, and then that number is smaller than another number, then the first number has got to be smaller than the last number. Or it works backwards. If this number is bigger than another number, and that number is bigger than a third number, then the first number has to be bigger than the last number. That makes sense. Think it through till it makes sense. Don't try to just memorize it straight. It should make sense to you. Okay, next. What happens when the same number is added to or subtracted from each side of an inequality? Well, 3 less than 6. That's true. So what happens if we add 4 to both sides? It stays true. What happens if we subtract 4 from both sides? It still stays true. What we're going to discover is this. The addition property of order. You can add anything to both sides of an inequality and it will remain true. Add or subtract. Now what happens with multiplication? That's a little different. If you multiply by 2, negative 4 less than 3, we're going to multiply each side by 2. Then we're going to get negative 8 and 6. Is negative 8 still less than 6? Yes. What happens if I multiply by negative 2? Oh, 8 is bigger than negative 6? It's actually not true. So a negative reverses the direction of the inequality when you multiply. So look at this next property. The multiplication property of order. For all real numbers, A, B, and C. So we've got 3 different numbers. C has got to be positive. If A is less than B and you multiply both sides by a number, a positive number, then it stays less than. If you have 2 numbers and you multiply by a positive number, it stays greater than. But suppose you multiply by something negative. You have to flip the sign. You have to flip the inequality. If A is less than B and you multiply it by a negative number, then AC becomes larger than BC. And if A is bigger than B and you multiply by a negative number, then AC becomes less than BC. And if you multiply both sides by 0, you lose the inequality altogether and it turns into 0 equals 0. That's an identity. Now the properties that have been stated so far guarantee that the following transformations of a given inequality always produce an equivalent inequality. An equivalent inequality is just another version of the same inequality. The answers will be the same. So here they are. You are allowed to substitute something that's the same on either side of inequality. You're allowed to add or subtract. You're allowed to multiply or divide by a positive number, and you can multiply or divide by a negative number as long as you flip the inequality. Okay, so let's try a couple of examples to see if we understand how this is going to work. Okay, so we have this first example, and it says to tell how to transform this one into the second one. So how are we going to get m minus 9 is less than 2 changed to m is less than 11? Well, add 9 to both sides. Okay? Just like you were solving an equation. How are we going to get negative 8k is greater than or equal to 16 to k is less than or equal to negative 2? We divide both sides by negative 8, and don't forget to flip the inequality because we divided by a negative number. Okay, example 2. Solve 6x minus 3 is less than 7 plus 4x, and then graph its solution set. Okay, we can do that. So I've got 6x minus 3 is less than 7 plus 4x. What we're going to do is let's add 3 to both sides. So now I have 6x is less than 10 plus 4x. Now I'm going to subtract 4x from both sides. 2x is less than 10. Then I'm going to divide by 2. And so I have x is less than 5. I don't have to flip the sign because I didn't multiply or divide by a negative number. Then it says to graph it. Okay, so I draw a line, put my 0, 1, 2, 3, 4, 5. Get 5 way out there. Negative 1, negative 2, negative 3. That's enough. Okay, now x is less than 5. So I'm going to draw an open circle on the 5 and then shade to the left forever because it's going to be every number less than 5. So that's the answer. Okay, let's do another one. Example 3. Example 3 says, solve this one. Okay. 2 times w minus 8 plus 9 is greater than or equal to 3 times 4 minus w minus 4. Okay, no problem. Let's do this. So, first thing is get rid of the parentheses on both sides. There we go. Now collect up everything. 2w minus 7 is greater than or equal to 8 minus 3w. Add 3w to both sides. 5w minus 7 is greater than or equal to 8. Add 7 to both sides. 5w is greater than or equal to 15. Divide both sides by 5. w is greater than or equal to 3. Then to graph it, put a 0, 1, 2, 3, negative 1, negative 2, negative 3. You just put as many numbers as you need. Now, 3 is my magic number, and it should be closed because it includes 3. And since it's greater than, I'm going to the right. Shade it all in. Done. Okay, let's do another example. These are all the basically the same thing. So, once you understand how the inequality part works, it's really the same as doing what you've already done with equations. Okay, this one's going to be a little tricksy, so watch what happens. First things first, get rid of the parentheses. So 4x is greater than 4x plus 8 minus 4x minus 4x. Uh-oh. 0 is greater than 8. That's false. And so there is no solution. There's no x that we can put in that would make this true. So sometimes if you end up with something that's false, then there's no solution, no answers, no graph. Okay, another one, last one. Y plus 5 is less than 7y minus 6 times y minus 1. Okay, let's solve and graph. First, get rid of the parentheses. There we go. Y plus 5 is less than 7y minus 6y plus 6. Notice the minus. Combine everything I can combine. So y plus 5 is less than y plus 6. Okay, then I'm going to do minus 5 minus 5 minus y minus y. So I'm going to have 0 is less than 1. Okay, this is true, and it's always true. So the answer is all real numbers. And to graph it, I'm simply going to make my number line and then shade the entire thing. Like that. Every real number would make this true no matter what. Okay, that's it. Let me know if you have any questions and get started.